Hi all. So in this lecture we will see about critical path method. So the previous lecture we have started scheduling, and in scheduling we have seen work breakdown structure and also activity on network structure. So in this, after completion of this activity on network, next step is to draw this critical path method. So CPM and PERT are actually operation research techniques that were developed in the late 1950s. So it was popular among those project managers. And later CPM and PERT were combined to form a single thing. But we will discuss CPM and PERT separately. Okay. So we'll define some of the terms that are used in CPM. First one is path. So a path, it is a path in the activity network graph. So we have already drawn that activity network graph. So it is a path in that activity network graph is any set of consecutive nodes and edges in the graph from the starting to the last node, from starting node to the last node. So it will be called as a path from starting. If there is a path from starting node to, you know that it is activity network diagram, it is a directed graph. There are arrows also. So if there is a path from starting to the end node, then it represents a path. Then what do you mean by this critical path? So critical path, it consists of a set of dependent tasks that need to be performed in a sequence and which together take the longest time to complete. So if there is a path which takes the longest time to complete, then that is known as the critical path. And all the tasks in it are known as critical tasks also. So critical task is one with zero slack time. We will see what is this slack time. So critical task will have zero slack time. So what do you mean by this critical path? So it is a path from the start node to the finish node that contains only critical tasks. So all the tasks in the critical path are known as critical tasks, and these critical tasks have zero slack time. So slack time or float time, it is actually the total time that the task may be delayed before it will affect the end time of the project. So if you take critical task, we cannot delay the critical task. So as soon as we are free that critical task should happen, we cannot delay any of the tasks in the critical task. So this is actually what is a CPM. So we have already seen this activity network. So this is same activity network we will use to represent the CPM. But inside this, instead of specifying the duration of each task, we will specify something like ES and EF. We will see what is ES, EF, etc. So we will be specified. So if you see, this is bold mark. So this darkened line means it is a critical path. So all the tasks will be critical task. And slack time means as soon as this 60, so it will early. This ES represents earliest start and earliest finish. So if it is started as 15 and it completes at 60, then this task should begin at 60 itself. That is, we cannot delay this task. So that is why it's a zero slack time. Okay. So this is also in a critical task, this design database. So if it is completed in 15 days, then in the 15 days itself, after 15 days itself, we have to start the design database. But if you consider this writing user manual, it has slack time because it is not in the critical path, because it requires 75 days to complete the work, and we can begin in 15 days. After 15 days, we can start writing user manual, but it is not necessary that we start from 15 day onwards, because the finish time is 285 and we require only 275. So the slack time is 210. We can start from the 210 day, then also we can finish without the delay. But all the tasks should, here all the tasks will have zero slack time. So here it is not 162, it is actually 165. There is some correction here. So we will see the different time that is used in critical path method. First one is the minimum time. So it is a minimum time that is required to complete the project. So it is computed by determining the maximum of all paths from start to finish. So it is a minimum time required to complete the project. Then there is earliest start time. So it is a time of a task is the maximum of all paths from start to this task. So it's the maximum of all paths from the start to this task. So earliest start of the previous plus the duration of previous task gives the earliest start time also. So this can be calculated like this also. The earliest start of the previous plus the duration of the previous task will give the earliest start time. Then we have another time called latest start time. So it is a difference between minimum time and the maximum of all paths from this task to the finish. So it can be computed by subtracting the duration of subsequent task from the LST of the subsequent task. We will see how to compute all these things in the example. So this is actually the definition. Then earliest finish time is there. It is similar to the earliest start time. It is a sum of the earliest start time of the task and the duration of the task. This gives the earliest finish time. Then latest finish time is there. So latest finish time indicates the latest time by which a task can finish without affecting the final completion time. So it is obtained by subtracting maximum of all paths from this task to finish from minimum time. Then we have the slack time or float time. We have already seen the slack time or float time. So it is a total time that a task may be delayed before it will affect the end time of the project. So some tasks can be delayed without affecting the end time. Then that time is known as a slack time. So this is the activity on network diagram. We have already seen this diagram. So from this we can draw the CPM. So what you have to do is you have to calculate the ES, that is earliest start time, earliest finish time, latest start time. Then we have the LF, that is the latest finish time, and slack time. So these are the times that are used in CPM. Now if you check that here, for specification we require 15 days. So earliest start time is 0. At the 0th time we can start this work, and the earliest finish time is 15 days. So within 15 days we can complete. That is why it is 15 here. And latest start, so how much we can delay that task? So we cannot delay that task because it is a first task that should be done. So that is why latest start time is 0. And latest finish, we can finish, we should finish within 15 days itself. And the slack time is 0 because at the 0th day itself, first day itself, we have to start the working. So that is why slack time here it is 0. Then next is a design database part. So earliest start time. So if you consider this earliest start time is, it requires 45 days. So earliest start time is 15 because after specification only we can start this. So that is why earliest start is 15. And earliest finish time. So how fast we can finish this? We can get it from 15 is the earliest start plus the duration is 45. 15 plus 45 it is 60. So we get as 60. And latest start time. So if we, whether we can delay this task for some extent, because we cannot delay because it is in the critical path. So this is a critical path. This blue line represents a critical path. So we cannot delay it. So the latest start time also is 15 days. So soon after the specification is over, we have to start that. That is why latest start is 15 and latest finish is 60 and slack time is 0 because it is in the, it is a critical task. So slack time is 0. Similarly for GUI. So similarly for GUI, so design GUI. So if you see this design GUI, earliest start time is 15 days. So after completion of specification, we can start it. So that is why it is given 15. And the earliest finish time, it requires 30 days. So 15 plus 30, it is 45 days. So within 45, we can finish it. And latest start. So latest start. So latest start is how we can get that latest start is we have to add all these things. So latest start, we have already seen the definition here. latest start time, it is the difference between minimum time and the maximum of all paths, or it can be computed by subtracting the duration of the subsequent task from the LST of the subsequent task. So that way also we can calculate it. So if we calculate that, so we will get it as latest start for GUI is 90 days. That is, even after 90 days, if we start this project, we can complete within that scheduled time. So that is why it is 90. So latest start is 90 here. And similarly, we can calculate the latest finish. It is 120. So that is 90 plus 30 gives 120. And there is slack time of 75. That is, if we make a delay of 75 days also, then there won't be any problem, because after 75 days also, if we start this work, we can complete as soon as this is complete, because this is not in the critical path region. And if you take this write user manual, so earliest start is 15 and the earliest finish is 75, because it can be completed in 60 days. So 60 plus 15, it is 75 days. But latest start is 225 days, because it has a slack time of 210 days. 210 days. It can be delayed 210, because the total of this time, minimum time to complete it, is actually 285 days. So it is 15 plus 45 plus 105 plus 120. So it gives around 285 days. So that is why there is, I don't know, the total is 15, 60, 60, 180. So 285. So 285. So it can have a slack time of 210 days. So after 210 days also, if we start this work, we can complete it, complete the work, because 15 plus 210 gives 210 gives 270, 210. So after 210 days also, we can start this work. Then also we can complete within 285 days. So that is why there is a slack time of 210. So that is how we can calculate. Similarly, we can calculate this latest start and latest finish also. So this is the CPM network. This is how we represent CPM using earliest start and earliest finish. And we can use another method also. We can use method is latest start and latest finish. So in both ways, we can represent this CPM, because so for the project managers, they can see whether this is happening on time. So this is actually for the project managers to monitor the project. So he can actually monitor. So he can monitor whether that code database has started in 60 days, and if it is completing in 160 days. So he knows when should be the latest start. So this the latest start of this one is 225 days. So it can be delayed up to 225, or it can be started earlier also. But latest start should be 225. If we start in 230 days, then there will be scheduled slippage. So in this way, the project manager can monitor the whole activities by drawing this CPM using these two notations. So that's all about CPM. Thank you.